Okay, hello, welcome back to another one of my video log recording sessions where I talk about genetic algorithms. The date is 2025 May 29th, and well, a reminder of where I left off last night, or in my very last video. I remember that I said in that video, I remember saying that I found a way to feed in somewhat somewhat normal looking, relatively normal looking distribution from a distribution of entities that result from a combination of learn rate methods and candidate methods and candidate percentage, and otherwise settings. I found a way to use that setting to ensure that entities, to ensure that some entities, more than one, keep hitting the true ceiling. Now, of course, while it does, well, yeah, I found a way to do that, and that was before this method was applied. A distribution like this worked. So only distributions like this one worked, where you can see that it's only like half a curve. So it's really quite skewed, and it's half a curve. And here you can see that this is the true ceiling. And what is a true ceiling, you might ask? True ceiling is the best possible, the most ideal state that an entity or an entity's chromosome could be in, given the utility values and the constraint values and the max constraint as well. So it is the best possible combination of genes, and so without the method that I used yesterday, entity distributions that looked like this, only the distributions that looked like this worked. So while trying to find a way, I found one, and that was while feeding in an entity distribution, or whilst using a learn rate method and a candidate method and a candidate percentage, while using the same setting that didn't usually work. The way to do that was to, well, set individual mutation rates depending on what rank they were for the entities. So set individual mutation rates for the entities depending on their rank, relative rank within that world per generation, where the mutation rate would be higher for the head entities and lower, higher for the tail entities and lower for the head entities. And for the very median entity, that's probably median, something like that. Let's just say this is the median. the entity or the entities in the middle or around the middle get to mutate at what was the previous base mutation rate, or the default mutation rate, being 0.03, and the highest mutation rate, which is for the tail entity, or the higher mutation rates for the entities with lower or low sum utility values, would be as high as 0.06, so that's 6%. And for the head entities, or the top entities, it would be close to 0 or 0%. It could be exactly 0 or not, very, very close to 0. Now notice how the mutation rate is linear, not exponential looking, and this also should remind you of the way I assigned the learn rate, because well, it was observed that if something like the learn rate, if something such as learn rate followed a somewhat of an exponential distribution, something like this one in blue or this in red, only the entities at the head or at the tail get a meaningful value for that thing. In this case, the learn rate. In this case, mutation rate. And when it comes to individual entities doing something, such as learning or mutating, if I want to have that thing to actually have an impact, it is I think it'd be wise to advise that I don't apply these kind of distributions. So if after having applied this, I have demonstrated that distributions like these could quite consistently and persistently hit the true ceiling. In this case, that is 1540. At the expense of slightly longer convergence time, or slightly longer period of time needed for convergence, as in it would take the entities slightly more in terms of generations to converge to that level per number of items, per step rather. Because if you remember, the sum utility plot for the world goes something like this. But with the now with the new method, that is individual mutation rates, depending on rank, it will take longer for the entities to converge, but given enough, supposing that enough number of generations per era, that is when the mutation, when the number of items change, but given that this time is enough, it is quite likely that the entities will converge and hit the true ceiling, and quite consistent, on quite a consistent basis. So that's where we left off yesterday, or in my last video, and I just wanted to re-explain, reiterate, and maybe clarify some bits, and explain or whatever, blah 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 blah. But anyway, so that I can actually think about what I in terms of context, I can actually think about what I want to talk about in this video log session. So that's that. And today, or rather tonight, yeah, it's 28 past midnight. Now, all this time, the premise was that the number of items increased. So it would start from 20, and then be 20, 10, 20, 30, 40, and 50. And theoretically, this could go on until like 100 items, and on and on and on until like 1,000 items. But that's too much. And the max constraint would also change. So something like 2400, 4000, 1400, was it 5000? And then 650, 6500, and then 9000. Yeah, I believe that was right. I could be wrong. So every time these changed, this was one era, this was one era, this was one era, this was one era, and this was one era. Now, I wanted to play with this around a bit more. So what I did this time was I had the number of items change somewhat irregularly. I mean, so far it was only increasing from 10 to 20 to 30 to 40 to 50. Now, I wanted to change that. I wanted to change the way the numbers changed. So first, naturally, I tried the descending or in decreasing manner. So it went from 50 to 40, 30, 20, and then 10. And the max constraint values also follow suit, something like that. So, for example, it would be 9000, 6500, 5000, 4000, 2400, I think. That was it. So that's the first thing I did. And the reason I did this was that I wanted to see if the evolution scheme. Now, evolution scheme is everything about the way I evolve the entities throughout the generations. It includes the hyperparameters, the way the hyperparameters are used, what procedures they go through, what processes that there are, etc., etc. So almost everything, or let's just say everything, for the sake of keeping it simple. Although I know that I'm way past that point of keeping things simple. But anyway, so I did that, and what I wanted to see was I wanted to see if the entities would hit the true ceiling, the true ceiling in that era. So in this case, by now I know what the true ceilings are. So for 50, it's 50 items is for 40. That's for 50 items. For 40 items, it's the sum utility value is 1135 for the true ceiling. For 30 items, it's probably 935. I'm just checking that. Let me just check that. 945. So for this, it's 945. For 20 items, it's 710. And for 10 items, it's 365. Do I have that right? Yes, I do. Yes, I have that right. So the purpose of this is to see if the entities, or if there are some entities that hit the true ceiling per era, regardless of the decrease or increase in the number of items. So here's the entity distribution. This looks strange, but you'll see why soon, because this is what it looked like. So in this case, the maximum ever being in this very case, the maximum ever was 1535. Now, this is not necessarily a bad thing, because by now we know that given the new method, that is assigning entities with their own individual mutation rates on top of everything else, it now takes slightly longer for the entities to converge. They will do so in the right window, or given wide enough of a window in terms of generations. But in this case, it could just be said that we were just unlucky and no entities ever hit the 1540 mark. But this is okay. But then again, we go down one step. That's when the era changed, and now the number of items is down to 40. Yep. And it does look quite apparent that well, actually, I can just rerun it. Let me just do that, So it is this one. I'm rerunning it on my laptop. I know I should find a way to show all of this, but it is what it is. So after 100 generations, that's we never hit the true ceiling for 50 items. Or not. Actually, I don't have to do this. I can just have a look at the no, not that. Okay, so keys. I'm having a look at the keys. Thank you. Where is it? Where's the head? Awesome. And show me from 200 to 300. Did I delete everything? I know I did, but I just want to now check. Oh, right. So, yeah, now I'm looking at the results from the JSON file, and I do see that for, well, this is until the 1st. It was 11:35, was it? Yep. So we do have the true ceiling hits in this era, and we have so in this era, and we have again the same in this era, and the same again in this era. Now, when they do hit the true ceiling in the next era, except for this occasion, the slight dip here, it seems that they almost instantly, almost instantly just hit the true ceiling, and they just stay there. Yeah. So well, I've just established that given the evolution scheme as it is now, it works for this kind of setup. And the next one I tried, oops, is next one is slightly more, well, not convoluted, but this, sorry, I just got a cough. Okay, the next one is where I have the number of items start from is that right? Number of items start from 50, and 40, and 30, and 20, and then 10. So it's slightly different here, is it? No. 50, 40. No. Did I do this wrong? Yeah, maybe I did, but maybe I reran it just to see if it worked. Maybe. Okay, I'll just show anyway. The next thing, I got that confused, mixed up, is the same setting now with, oh yeah, I remember. I reran with the same settings just to see if the true ceiling for 50 items could be reached, and in this case it did. Something happened there that caused a leap, and almost immediately, as the era changed and the number of items decreased by 10 items, they do fall down, of course, because now they can only take entities can only take fewer genes, but almost quite immediately they hit the true ceiling, so that's good. Except here, something weird happens here, but I think that's a very item specific or items and values specific thing right here. It could be that the decrease had the decrease in the number of items and the number of genes deleted or took away a lot of the optimum combination of items, so a lot of the information was lost, and therefore with fewer genes now, a new version of good entities or good combination of chromosomes had to be devised, because when this fall happened, when this drop happened, a lot of the information was lost. Oh yeah, but no. So yeah, so the true ceiling given 50 items is still reachable, so that's good. In the very next one, so this is the third. This is the third setting. Next one, I did 50 items, and then it was 30 items, and then 10 items, and then 20 items, and then it was 40. And when I do that, this is what I get. So it is still quite apparent that given enough generations, it will converge to the true ceiling. The entities, some entities will still keep converging to the true ceiling. So overall, so far, the evolution scheme is doing its job quite well. And the last setting that I tried was where the number of items goes from 30, starts from 30 and then 40, all the way down to 10, up to 20, and then suddenly back up to 50. And here is the plot for that. And even when this is the case, you might think that it would be quite hard, because when we had a look at a gradually decreasing number of entities, it didn't converge to the true ceiling. Of course, given maybe 10 more generations it would have, but it didn't in this short amount of time. This is 100 generations, by the way. So when we have 30, 40, 10 to 20 and 50, when we would go from 10 to 20, it's quite likely that it will converge within 100 generations, because this is such a small number of genes from 10 to 20. But then again, going from 20 to 30, the difference is 30 genes, 30 items. So it could be a bit of a stretch. You could feel that way, to think that the entities would converge, to feel that some entities would converge to the true ceiling. That doesn't show well. To this true ceiling. Black is better. To this true ceiling within 100 generations. But it did anyway. So, of course, going from 0 items and then 50 items and converging within 100 generations is harder than going from 20 items and then to 50 items and starting halfway there. But, you could have felt that. I could have. I myself thought this could be, not given, not guaranteed, but it happened anyway. So the conclusion is that the evolution scheme is doing its job quite well. And I wanted to see the next thing, in the next 4 cases, I wanted to see if similar results could be attained by. Let me see that. So this is the plot from the last video. This is one of the first times that I applied the individual mutation rates, and I wanted to see if I could do the same but have somewhat of a responsive era change, adaptive era. So the core concept there is that I would like to have the entities evolve given a number of items until it could be said that a supposed true ceiling has been met. Now, in actual life, or in real life, real problem, or in terms of actual life and genetics, you often don't know or cannot know if you have actually hit the true ceiling. But again, the way I did that is, in this case, because now I know, well, for now I know, I could have the era change and move on to the next era as soon as the true ceiling has been hit, or that's the first thing I did, and then I could have the era change when the true ceiling has been met maybe 3 times, then after that is 10 times. So the moment, for example, I'll just use a rectangle. So the moment the summed utility value hits, zoom in for that. The moment the summed utility value hits 365, this is 365, the era will change. The era will change. It's not so straight. This is good enough. And then the next era will start until the entities converge to the next true ceiling. That is 710. So this is 710. And then the era will change again. Move on to the next era. You get the gist now. And then it will go up, and then the moment it hits, what was it? 945. The next era, the moment it hits, the moment it hits 1135, next era will start until generation 500. Until generation 500. So this is 1540. So this is what I wanted, and if I set the true ceiling count to 1, the era will change as soon as it is met. If I set it to let me just write that, true ceiling count, is it max? True ceiling max count. If I set this to 1, the era will change as soon as it is as the true ceiling is hit. If I set this to 3, it will wait until that's been done 3 times. If I set this to 10, you know what will happen. Until 10 times it will wait. So I did that. Oh yeah. So I did that. This is what I got. So notice how where'd it go? Notice the similarity there. That's better. See how similar it looks? Not that similar, because I am not a good painter. But anyway, it works, and the true ceiling has been met, as you can see, 1540. And for the first 4 number of items, that's 10, 20, 30, and 40. it takes quite a bit of time, I mean almost no time at all, for the entities to converge. I'll just read it up for you. So in this case, for 10 items, it only took 12 generations to converge, and then for 20 items it took 22 generations. For 40 items, so wait, let me say that again. For 10 items it took 11 generations to converge. For 20 items it took 22 generations. For 30 items it took 43 generations. Yep. And then for 40 items it took about 98 generations in this case. That's 10, 20, yep. And then for 50 items it took about the same, I guess, to hit the true ceiling, that is. When the true ceiling max count was set to 1. And I did the same thing again, just to see if this was an anomaly, and yeah, so it really wasn't, because this is very similar, and we still have the true ceilings. And in the second run of the same setting, with the same setting, for 10 items it took 8 generations to converge. For 20 items it took 23 generations. For 30 items it took 31 generations. And for 40 items it took 85 generations in this case. So it actually took shorter for the entities to converge in the second run, just by sheer luck, I mean. But if I were to do a third run with the same setting, it could be different. It could take longer, it could even be shorter, but all we need to know now is that they do converge. Of course, we've already established, as we have already established, that for every number of entities so far, even until 50 items, they all converge within approximately 100 generations. So the next thing I did is set the true ceiling maximum count to 3, and here's what we got. And for this, the eras changed, as in the entities quote unquote converged in 8 generations, and then in 29 generations, then in 32 generations, and then in 98 generations. So about the same. This is when the max count was set to 3. And then when I set it to 10, this is what happened. Again, it worked. And in this case, of course, it did take longer for the eras to change, because now it had to wait until the true ceiling was met 10 times. Not in a row, but a total of 10 times in each generation, in each era. So the first era changed after 21 generations, from the second to third in 30 generations, and then it took 45 generations, and then it took, wow, 86. Is that 86? No, 76, sorry, in 76 generations. So in this case it actually took less time for the era to change, when it moved from 40, when the number of items moved from 40 to 50, in the last 2 eras. And one of the reasons that I could probably guess why that happened is that while the entities had to wait for the era to change and for the max count, true ceiling max count, to reach 10, more entities converged in that era, and then as now there are more entities with somewhat better information than 10 generations ago or 20 generations ago, it became more likely that that would have happened during what I'm saying would have happened during this era, these 2 eras. But anyway, while the entities had to wait for the max count, true ceiling max count to reach 10, become 10, more and more entities got to come close to being converged, and that would naturally lead to better outcomes, or somewhat better outcomes. But in this case, almost definitely better outcomes as the era changed from here to here, and then this would affect how the entities do in the next time the era changed. So not just this era change, but the next era change as well. That's why it would take shorter generations or fewer generations as the era changed for the entities to converge. So that's that for today. I mean, that's it. I'm still wondering what I should do next in my next video, or for my next video. I could have one last go where I increase the number of items to 100 so that we get something like this forever. Yeah, I can try that. And of course, to do this I would also need to change the population. I would need to increase the population, because if we have more genes or more items, I found out about a month ago while I was doing the max constraint percentages for 10 items, for 40 items, and then for 1,000 items, no, 100 items. The peak plateau plot wasn't actually reaching what it could be or what it should be, so I may need, or I should need, more entities within that population as the number of items grow. So I think that's the next video. Thanks for watching. Goodbye.